Under the IndiaAI Mission, the national strategy is defined as AI in India, AI for India. The objective is to build sovereign foundational models trained on local datasets and Indic languages. This domestic development supports a broader strategy of digital diplomacy. India aims to export its digital public infrastructure, or DPI, to emerging nations across the global south. This infrastructure includes systems like Aadhaar, shown here, which provides a biometric identity layer for a government to digitize civic services. The financial component of this export strategy relies on open data exchanges and digital payment systems, such as the BIM UPI QR codes visible at this checkout counter. By providing these systems, India positions its domestic architecture as a foundational layer for developing economies in South Asia, Africa, and Latin America. In August 2026, Moonshot AI released the Kimi K3 model. As this strategic assessment notes, the release represents a challenge to the existing IndiaAI roadmap. The scale of the model is 2.8 trillion total parameters. For context, this dwarfs the 1 to 70 billion parameter domain-adapted models typically targeted for sovereign development. K3 features a native 1 million token context window, enabling native visual spatial understanding and long-horizon autonomous reasoning capabilities within a single model core. The strategic pressure stems from K3 being an open-weight model. It is cost-free for any developer or enterprise to download and deploy. For Indian policymakers and startups, the availability of free, frontier-grade intelligence alters the economic calculus of building foundational models from scratch. Large models usually present a financial barrier at the point of use. Running nearly 3 trillion parameters would typically require massive compute budgets, but K3 was engineered to lower those operational costs. This K3 sparse mixture of experts pipeline uses 896 specialized experts, but only 16 are active per token. Kimi Delta Attention replaces standard quadratic attention, enabling 1 million token processing. Finally, native MXFP4 quantization reduces the VRAM footprint, allowing multi-node GPU deployment. These architectural breakthroughs make K3 so efficient that building a local model from the ground up becomes difficult to justify for independent developers. Training models at this scale requires an industrial base capable of supporting mega-scale compute clusters and massive power integration. Currently, the IndiaAI Mission aims to deploy roughly 10,000 GPUs, significantly smaller than the industrial clusters used to train frontier-grade models like K3. India is working to bridge this gap through the Semicon 2.0 initiative, establishing chip manufacturing hubs and cleanrooms in Dholera and Morigaon. This hardware expansion is visible at industrial sites like this one in Sanand, where the government is building out domestic manufacturing capacity. Despite these efforts, the capital expenditure gap makes it difficult for private Indian startups to match the compute brute force of state-backed foreign clusters alone. Because of training costs, Indian tech companies are incentivized to build application wrappers around K3 rather than training their own base models. As the diagram shows, this creates an architectural dependency. The domestic developer ecosystem ends up operating on top of Chinese foundational intellectual property. This puts immense economic pressure on local ventures like Krutrim and Sarvam AI. They must now compete with a top-tier reasoning engine that is available to their customers at zero license cost. Geopolitically, these open-weight models serve as digital soft power, positioning specific base architectures as the default intelligence layer for developing nations. If adopted as the standard, Kimi K3 could replace India's DPI stack as the default digital infrastructure for emerging economies. To maintain autonomy, India must shift to an asymmetric response. First, direct pre-training budgets toward domain-specific specialization, like Indic speech. Second, establish national security nodes for air-gapped hosting of foreign models without external telemetry. Third, provide GPU grants for lightweight, edge-ready frameworks. By focusing on localized datasets and secure hosting, India can utilize global advancements without surrendering its data sovereignty. The global AI race is no longer just a contest of model intelligence, but a contest of architectural ownership. True technological sovereignty requires a nation to maintain ownership of the intelligence layer powering its society, free from external architectural dependency. Without this asymmetric defense, The AI for India initiative risks being reduced to an application layer built on foreign foundational IP.